Okay, so thank you for that introduction, Roger. And the conclusion of what you've told me, Roger, is that what we're trying to do is to investigate the impossible. And if we get a result, that will be brilliant. So that all of those variables are going on, and there's a big problem for sure. But it's worse than that. And I'm showing you here a picture of the famous, or rather infamous, Western Electric Company plant called Hawthorne. And in the 1920s and 30s, apocryphally, they did a lot of lighting research here. And what they found was every time they changed the lighting, productivity improved. And that's simply because people, if they think somebody's paying attention to them, investigating how to make things better, their attitude becomes better, and therefore they work better. So as well as all of the issues Roger's pointed up, we've got this massive psychological problem. So that limits the scope for the experiment. We couldn't, for example, give half the people in an office a nice dose of light and not give anything to anybody else and use them as the control, because the people who would be in the control would very quickly pick up on the fact that there's something wrong. Psychologically, they would feel left out and their reactions are not likely to be the same. There's a further complication in that we do not know what the metabolic impact of the extra light is. We're all quite familiar with light interacting through melanopsin and so forth. We're far less familiar, and we're starting to be, with light directing into mitochondria and stimulating the mitochondrial system and improving metabolism. And we know that this is starting to have big improvements in vision if we start stimulating the metabolism in the eye with red light, but we're yet to fully understand that result. So we've got to try to design all of these things out of the experiment. And so we have a big problem. We have a group of people who we want to test. We mustn't let them know whether they're being tested or not, because if they somehow think, oh, I've got a test condition today, I must do well because it's bright light, and there's emotional baggage that comes with all of this, so we have to try and avoid it. So that limits the scope for the experiment, but hopefully it does mean that if we find anything, we can rely on the results because we've eliminated as much as possible. So the tactic we use is to try to match perceptions. So every morning, as part of the experiment, people in the experiment were issued with this particular task light. And every morning they switched on at exactly the same level. And after a little while, they adjusted to the level for the day. And as you can see, if we go through, these squares are not, apparently each is not changing in brightness from 1 second to the next. However, if you look at the two of them together, you'll see that the one on the left is darker than the right, but none of them have changed. And this gives us a way in, because perception of brightness, when it changes slowly, is generally not noticeable. Brightness perception is generally relative. So long as there's a good spatial distribution between these two sources, then we can manage well. So here we have the case where we have two sources, one's a factor of 2 brighter than the other, and we can achieve that. The other thing we need to do is make sure that if there are more than one of these lights in an office, if one day they are on the high condition, then all in that office are in the high condition, so people can't wander around and say, my task light's brighter than yours. So by doing that, we've eliminated as much as we possibly can of the psychological impact. And so we're comparing the same people on different days, some days with a relatively high luminance task light and on some days with a relatively low luminance task light. So with the limits that we could get apart from those two effectively were that a factor of 2 was about as far as we could stretch that experience without the risk of people noticing. If people started to notice, then we would have had problems, and then we would have started to get psychological impacts as well as physiological. The luminance change must be slow, but there must be no clue to the subject. So whether they're on the bright, which we will call the test condition, or the low luminance, which we call the control condition from here on in, they get the same questions throughout the day, so they have no cues as to whether they are on a control or a test condition. And roughly speaking, if we have this little task light here, we tried to set the control condition so it gave them, when it was set up, about 125 medilux, and in the test condition, around about 250 medilux. We have, roughly to give you an idea, that's where these values are in this KSS scores diagram. And so by positioning them there, we should have got the maximum physiological impact for the amount of stimulus difference that we could supply within the domain of the experiment. And just for reference, here is the spectrum of our source. It's a standard good color rendering 4000 Kelvin light source, a very typical sort of LED that would be used in almost any office. For comparison, there's D65, and D65 is what is used as part of the evaluation of medilux in its definition. So, what data did we collect? Well, every morning, people were reminded to sign in and fill up a web page. We asked questions about the previous night's sleep, sleepiness and mood. And then the sleepiness and mood questions were repeated in the afternoon. And we also collected comments from those people during the course of the day. There was also, at the end of the study, what we would call a semi-structured interview, where people were asked in general terms how they got on, and they were steered gently to certain topics, but we avoided outright questions because that potentially could give problems with people asking things and answering things that they didn't really know the answer to. So the mood question, we used a set of adjectives and asked people to select the adjectives that best described how they felt that day. And here we see a standard sort of mood, and you can, those of you who have done this sort of thing before will recognize that these are the sorts of adjectives we quest so that we can work out where people are in the standard circumplex model of mood. And so we'll typically characterize this by valence in this direction. So over here, over here would be very happy, over here, very sad. And arousal, so this would be excited, energetic, all those sorts of things. And down the bottom would be sleepy. So using those two dimensions, we had a series of words that could plot where you were. We just took those words in and we processed them to calculate an average mood for each of the mood surveys. We rather than use the full Carolina Simpliness scale, which is a bit complicated to apply, we did a slightly short version, and this has been trialled extensively, particularly for use in children and in schools, and this is quite a reliable tool. So we used a derivation of this, and we just used pictograms and asked people to pick which pictogram fits them best. So we had a daily test routine. We asked people, how did you sleep? We did a sleepiness scale and mood words. And then we had, in the afternoon, a sleepiness, mood words, and a general question about how your day went. So a relatively small change. So the expected result is the stimulus change is relatively small to the number of things going on. So if we find anything going on at all, it will be a little bit, it will be not totally unsurprising, but to find something that's measurable reliably is likely to be difficult because they're only experiencing part of the office. And as Roger said, there's so many other ingredients in the soup of their lives for that day. But the other thing we would get is that the bigger question is, would such a light source be acceptable to everybody in the office? Yeah, we could see lots of potential problems with this light source on the desk. So at least we would guarantee that, or would have a good knowledge of that towards the end. But there's also the bigger issue of would we expect the difference in mood that we'd expect to see between the test and controlled conditions? We would expect it to be relatively small, but it would be nice to find it. And if we did find it, it would be found in a very reliable way. So moving on, as always, when you're using questionnaires, you need to devise a means to validate the answers. Yeah. There's so many people write questionnaires and people fill them in. And by the third question on the second day, most people get totally bored and just tick boxes to make it go away. So we needed to put in a tool so that we could check whether the answers were sensible. And we did that through the mood words. Clearly, with all of those adjectives, there were possibly of being antonyms for some of them. In fact, all of them had an antonym or more. So if we found 2 antonyms coming up in a mood response, we knew that that day that subject wasn't paying proper attention to this, and so we could delete that record from the system. So to give you an example, if somebody said in the same mood response that they were at ease and alarmed, then we know they're not really paying attention. And so if they're bored and astonished, that's unlikely. So that gave us a very quick tool to validate the answers and make sure that the person filling it in was actually paying attention. So we did some data cleaning and we had some rules under which we could do that. So the requirement was that we must have from each subject a minimum of 3 days under each lighting condition. And that worked for everybody but one person. For some reason, because they were in and out the office on different days and never quite lined up, they had done 2 days in one condition and 20 days in the other. And so we had to reject them. And the other thing that caused us to reject people was that we found that one subject always used the same 3 mood words for mood adjectives every time. So clearly they just decided their boss wanted to think they're hyper attentive, active, and all of those sorts of things and happy in their job. So they just put the 3 mood words that indicated that in every time. And so we had to reject them from the survey. So we ended up with 491 records from 28 different subjects at the end of this study. So what we did, first of all, was for each mood, calculated the average. So each word has a valence and activation score. And simply following this on, if somebody had said relaxed, content, and calm, so relaxed has a valence of 0.58 and an activation of minus 0.72. So relaxed means fairly inactive. Content, similarly, and calm, we can similarly score. We just take the average and plot it for them. And so there, once we have mood and activation, we can start to plot the results. And doing a box and whisker plot, we can see generally for valence, generally this indicates that, first of all, between morning and afternoon, people seem to be happier. Or shall we say that there are less people feeling unhappy. Now, maybe that's the prospect of thinking, yes, I'm done for the day, I'm about to go home. I don't know. It may be that they all love being in work and they think it's fantastic. I don't know the why, just know the is. However, what we find is that there's a difference between the test condition. So if we compare that to that, the test condition shows that there are far fewer unhappy people in the morning. And similarly, there are fewer unhappy people in the afternoons in the test condition than in the control condition. Arousal is fairly similar. Broadly speaking, there is very little by way of difference between any of these scores, and the way they plot is neither here nor there. So I would have said, incidentally, I'm not diving into statistical information here. The problem that we have is we have a data set which isn't deep enough for true statistical analysis given its width. I'm sure we could pour this data in SPSS and we would come out with a very significant statistical answer to, and it would say there's a probability of massively high. But because the data set is effectively wider than it's deep, we would fall into the trap of so much experimental psychology and sociology, and we would get into the zones of being unrepeatability, which is the plague of that subject domain at present. So we deliberately have not done that. We've laid out the data as is. The sleepiness versus alertness, there's a bit of a difference there in that we get, with the test condition in the morning, we get an apparently much higher alertness, a little bit there, but that's an important thing to note. So it's going in the direction we would expect. A lack of sleep, it reduces sleepiness in the morning a little bit. Now, this study, then we could look for, in some subjects, on some days, we could think about perhaps can we follow up what they did, how they slept the night after a condition the day before. So in the morning, they filled in a sleep questionnaire, which they were given a set of adjectives to describe their sleep. It could be bad, it could be patchy, fair, good, or exceptional. Now, we have, as I said, we had something like 480 records, 490 records of people doing, but because of things like weekends, people not working the following day in the office, we only got just over 200 conditions where people had worked 2 days consecutively in the office, and where that happened, we were able to pick up. And so if we knew what they'd slept before, and generally we find that bad and patchy sleep tends to follow the control day slightly more than it follows the test days, and exceptional and good sleep is slightly more common after the test days. So that would align with our theory that would say this light source should promote better sleep because people are slightly bigger light dose during the day. Now, this is a reasonable, I hope you think, is a reasonable exercise in the blatantly obvious. In that, if you had a good night's sleep, you're likely to be less sleepy the following day. And if we look at the averages, if you have a bad night's sleep, you have a relatively high sleepiness score. And if you have a really good night's sleep, you have a lower sleepiness score. Interestingly, during the afternoon, it tends to revert to the mean. So here, people who had a really bad night's sleep, by the next day, by the afternoon, they're feeling slightly more alert. People who came in brilliantly alert in the morning are getting slightly more tired in the afternoon. However, if we look, both of these are straight lines going, diagonal lines going down. So I don't think it would have to be a genius to predict this, but it's always good to know that your data is telling you what you expect. Now, from diary comments, we found a whole series of comments. 16 comments from 15 subjects suggested things about feeling comfortable, liking the light. 11 comments talked about more alert, and 9 comments about improved mood. Now, let's be careful about how we had this. These are about comments that came in. They are not related to whether they were on the test day or the control day. This is just general people commenting about the fact they've got a task light. So these may well be psychologically derived rather than physiologically derived. There are some comments here about negative things, irritating, lack of control, and too bright. And we got 14 of those comments from 13 different subjects. So one of the key things from that negative comment is if the light was user controllable, that comment would effectively be nullified. So if the production light fitting had a dimmer control or was able to be switched off, that negative comment could be removed. But clearly in the experiment, we couldn't permit that because life would get far too complicated. From the post-study interview, there were about 30 comments about the light, of which were all positive, and 24 comments about alertness, which were all positive. Negative comments about the light, there were 9 comments from 9 subjects, and there were no negative comments about alertness. So again, if the light became controllable, it would effectively, we know it could be universally acceptable. And then just to move, the post-study sleep interview, 10 people reported a positive effect, no people reported a negative effect, and 10 people reported no noticeable effect. So let's conclude this, and then hopefully we got time for a few questions. Most subjects found the light source acceptable, and the majority found benefits to its use. There were some negative comments, but these could be quite resolved with individual control. Results tend to show that the use of the light improved valence, i.e. happiness, and sleep the following night, and reduced sleepiness during the day. Just put a caveat to that, there are a lot of competing variables. The study is small, and in anything like this, the impact is small because of that. However, it is all the effects are there that we would expect to find. They're just relatively small and harder, not perfect in terms of quantification. And finally, 10 subjects reported improved sleep during the trial. Okay, that about wraps up what we need to say.